Math time!
Before going any further with our discussion today, let us have first a short drill. Let's take a look with the first box. Is a parallelogram a quadrilateral? Yes, indeed. Parallelogram is a quadrilateral. But how about if this would be the question? Is quadrilateral a parallelogram? Well, we've got a lot of questions in our head. It might be saying yes or no. Now, is there any exemptions, rules, or even conditions that we might say yes, that a quadrilateral is a parallelogram? Well, that's why today we will be talking about conditions that guarantee that a quadrilateral a parallelogram. And to start with our discussion today, let us have first a short review about quadrilateral. When we say quadrilateral, it is a closed plane figure consisting of 4 line segments or sides. And parallelogram is a quadrilateral with 2 pairs of opposite sides that are parallel. Now let's talk about the conditions. What are these conditions? Well, the first condition says that a quadrilateral is a parallelogram if both pairs of opposite sides are congruent. Now let's take a look with this illustration. We have here quadrilateral STAY. Okay, it's this one. STAY. We have segment SY. What is the side opposite to this segment SY? Well, of course, this would gonna be segment TA. So, based from the indicated measure, that segment SY is congruent to segment TA. On the other side, you have here segment ST is opposite to segment YA. As indication that segment ST is congruent to segment YA. Alright, so let's now have our example. So let's take a look with this example. Stay is a quadrilateral. Determine the length of segment SY or side SY that will make stay a parallelogram. Okay, with the given, of course, that side ST is 10 centimeter while side YA is 10 centimeter. And segment TA, this one here, is 12 centimeter and we're looking for the side SY that is represented by X. For our solutions, knowing that segment SY is congruent to segment TA. No problem with these sides here, these two sides. So from here, that segment SY is congruent to segment TA. So as we substitute, SY is equal to X and TA is equal to 12 centimeter. So therefore, segment or side SY is equal to 12 centimeter. In that way, therefore, segment SY or side SY must be 12 centimeter to make stay a parallelogram. Alright? Now let's have another example. Okay. So, calm is a quadrilateral. We are asked to determine the value of X that will make calm a parallelogram. So, take a look with this one. So, no problem with this side and that side. This is already 13. We have here side CM and side AL. And we're looking for the value of our X. How are we going to do that? Well, of course, we have to follow the condition number 1, that this side in here is congruent to that side. So therefore, you would have to solve for X, segment CM is congruent to segment AL. Okay? And segment CM is equivalent of 3X minus 5. Again, we used to have the equal sign here as we are going to solve the values of our x, not anymore the congruent sign. So AL again, x plus 7. So to solve for x, we have to transfer this x here to this side, and the negative 5 will also be transferred on the other side. Okay, we will apply such property. That could be addition property of equality and subtraction property of equality. So therefore, you have 3x minus x equals 7 plus 5, and simplifying 2x equals 12, dividing both sides by 2, you would have it there as x is equal to 6. So that is 6 units. Now, it is not being asked in here that we are asked to find how much is that segment CM or side CM as well as segment AL. So to solve for the length of segment CM or side CM, we have to substitute the value of our x to the given. Side CM is equal to 3x minus 5. So as we substitute 6, that becomes 3 times 6 minus 5. So 18 minus 5 therefore is equivalent of 13 units. And that is our segment CM. So it's not x. That is segment CM or side CM here. And also for the segment AL, we have AL is equal to x plus 7. So x is 6. So we have 6 plus 7. Therefore, you would have 13 units. So side AL here is 13 units, just like in our side CM. So in that way, we concluded that the x value must be 6 units to make calm a parallelogram. Alright? So I think that's very clear. Now let's proceed to condition number 2. What does condition number 2 states? Well, it says here that a quadrilateral is a parallelogram if both pairs of opposite angles are congruent. So in this condition, we are now talking about the angles. So right here, we have angle F. Opposite to that one is angle S. Okay? And we have that angle F is congruent to angle S, while angle A is congruent to angle T. Okay? So you have it there. The two angles, F and S, A and T. These are the opposite angles. Okay, let's take for example. FATS is a quadrilateral. Okay, here is. Determine the measure of angle A. Where is angle A here? So this here. Angle A that will make FATS a parallelogram. So from the given that angle F is 110, congruent to angle S, which is also 110, and angle T is 70 degrees. So therefore, without any solving, you could have angle A is equal to 70. To show your the solution, we have here angle A is congruent to angle T. So since angle A is known as X and angle T is 70, so therefore X is equal to 70. And angle A therefore must be 70. So in that way, as we can conclude that angle A must be 70 degrees to make FATS a parallelogram. Okay? Let's now have next example. Boys is a quadrilateral. Let's take a look. Determine the value of x that will make boys a parallelogram. This problem, 60, angle O, angle S is 60. These are opposite angles. And angle B and angle Y are also opposite angles. That means, as our solution, okay, angle B is equal or congruent to angle Y. To substitute, angle B is 120, then angle Y is 4x. So you have 120 is equal to 4x. And we're after of the value of our x. So what shall we do? We are going to divide both sides by the numerical coefficient of x, which is 4. So dividing both sides by 4, you would have it there. 120 divided by 4, that will give you 30. Okay, so the value of our x is 30. So x must be 30 to make boys a parallelogram. Why? What is 4 times 30? That is equal to 120. Okay, are there questions with this condition? Next up, let's proceed to condition number 3. A quadrilateral is a parallelogram if any pairs of consecutive angles are supplementary. Okay, so based from this illustration, we have here quadrilateral TONE. And it says here consecutive angles are supplementary. So what are the consecutive angles? So let's start in that direction. Okay, starting from that one, there, going there. Okay, so that the measure of angle T plus the measure of angle O is equal to 180 degrees. Again, supplementary angles, it always measures 180 degrees. Next up, we have angle O, this angle here, plus the measure of that angle N is equal to 180 degrees. Angle N plus measure of angle E is equal to 180. And lastly, we have measure of angle E plus measure of angle T is equal to 180 degrees. Okay, so let's now have an example. So tone is a quadrilateral right here. Determine the value of x that will make tone a parallelogram. So again, that the measure of angle T is congruent to that one and that one. We actually we don't need anymore to solve or show solution here, but as of this moment, let's apply condition number 3, that angle T and angle E are supplementary angles. Okay, so measure of angle T plus measure of angle E is equal to 180 degrees. To substitute, that would be 120 measure of angle T, measure of angle E is x is equal to 180. Okay, so 120 plus x is equal to 180. So we will going to transfer 120 on the other side. So that's why 180 minus 120. So what is 180 minus 120? So therefore, you would have x is equal to 60 degrees. Okay? I think that is very, very clear. Now, therefore, x must be 60 degrees to make tone a parallelogram. Okay. Now, let's proceed to condition number 4. What is condition number 4? A quadrilateral is a parallelogram if the diagonals bisect each other. Okay. So we have here quadrilateral or parallelogram solved. S-A-L-T. So if we're going to connect vertex S to vertex L, you would have a diagonal. And so with vertex T and vertex A, we could have a pair of diagonals. Okay, so you have it here, that one. They bisect each other. When you say the word bisect, it means it is being divided into two equal parts. So let's assume that this point in here, their intersection of our diagonals as point O. So in that way, that segment SO is congruent to segment LO. Okay? And so with segment, you have it here, SO is congruent to LO, and segment TO is congruent to segment AO. Let's take for example, we have here, SOLT is a quadrilateral with diagonals SL, okay, this one, and AT, intersecting at point O. We are asked to determine the length of LO, where is that one? This one. That will make SOLT a parallelogram. With the given, of course, that segment AO is 9 cm and segment TO is also 9 cm. As well as segment SO is 6 cm and segment LO is X. For our solution, knowing that segment SL is being bisected, okay, so that segment SO is congruent to segment LO. So we will now substitute. SO is 6 cm while LO is X. So substitute, you have it here. Therefore, segment LO is 6 cm as well. So that means to say whatever the length of this segment will also be the length of that one. So if you will be asked how long is segment SL, that would be of course 12 cm. And 80 would gonna be 9 plus 9, a total of 18. So in that way, LO must be 6 cm to make SOLT a parallelogram. Okay? Okay, condition number 5. A quadrilateral is a parallelogram if each diagonal divides a parallelogram into two congruent triangles. Will it really make a triangle? Let's try it out. Okay, so we have here diagonal LN. So is there or are there triangles formed out from that diagonal? Well, of course, you have that triangle and this triangle here below. Okay? And as well as this one. We're going to draw a diagonal in that way. So, well, of course, there are two triangles formed. Okay? So, we have triangle LAN and triangle NDL. But of course, we have here, we have to consider the corresponding parts. Okay? So, triangle LAN is congruent to triangle NDL. That segment LA is congruent to segment ND. And segment AN, this one, is congruent to segment DL. Okay? On the other side, we have here triangle LAD is congruent to triangle NDA. That segment LA, this one here, is congruent to segment ND. This one. And so with segment LD or side LD is congruent to side NA. Let's take for example. LAN is a quadrilateral. This one. Name the triangle that is congruent to triangle LAD. So we have here triangle LAD. That will make LAN a parallelogram. So the right color here, okay, that is the triangle that we are going to identify. Okay, for our solution, therefore, you would have triangle LAD. So since we started with LAD, so we must start with NDA. Or triangle NDA. Okay? So in that way, therefore, triangle NDA must be congruent to triangle LAD rather, to make LAN a parallelogram. Okay, next up, condition number 6. A quadrilateral is a parallelogram if one pair of opposite sides are congruent and parallel. This is very clear already. I think There's no need for us to give an example for this. But anyways, we have here that segment CA, this one, is parallel to segment AR. And segment CA, therefore, is congruent to segment ER. And so with the line here, we have line CA and segment ER. That is the parallel sides. In that way, let's have now example number for condition number 6. Care is a quadrilateral. We are just asked to name the side parallel to segment CA and the side congruent to segment CA. That will make care a parallelogram. Okay, so based from here, for the parallel sides, you have segment CA is parallel to segment AR. And for the congruent sides, we have segment CA is congruent to segment ER. Thus, CA must be congruent to segment ER and CA is parallel to segment AR for us to say that care is a parallelogram. Understood? Okay, thank you so much for listening. That is all about the conditions that guarantee that a quadrilateral a parallelogram. Hoping that you've learned a lot from our lesson today, and God bless. Thank you for watching.